For the last 50 years, human spaceflight has stayed close to home. We've remained in low Earth orbit, relying on the protective embrace of our planet's atmosphere and magnetic field. The International Space Station is the pinnacle of that era. It's a magnificent research facility, but it anchors itself firmly to our cosmic shoreline. Artemis II breaks from that shoreline. 4 astronauts are strapping into the Orion capsule to sail hundreds of thousands of miles past the moon, out into the deep, hostile waters of space. Before we can construct long-term lunar habitats or plot a course for Mars, we have to prove that our engineering can actually keep a crew alive in the darkest, most isolated environment imaginable. The crew taking this test flight includes Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen. Escaping Earth's gravity well demands raw, violent power. The Space Launch System rocket generates millions of pounds of thrust to push the Orion capsule out of the atmosphere, but the crew doesn't immediately head for the moon. About an hour after liftoff, they settle into a high Earth orbit, entering a mandatory waiting period. This pause is strictly tactical. The crew takes manual control to test drive Orion's life support, navigation, and proximity operations. If a critical system fails here, they can still execute a rapid abort and splash down safely. This animated diagram illustrates the moment the mission shifts. Once the systems check out, the upper stage engine fires for the translunar injection burn. The spacecraft breaks its circular orbit and accelerates outward into the dark. Crossing that invisible boundary strips away the option for a quick rescue. The Orion capsule immediately ceases to be a simple transport vehicle and becomes an isolated, self-contained survival bubble. Outside the Van Allen radiation belts, the vacuum of space is entirely hostile to human biology. The spacecraft is now completely responsible for manufacturing a miniature, functioning Earth inside a pressurized cabin. Every exhale from the 4 astronauts releases water vapor and carbon dioxide. In a perfectly sealed metal box, that continuous natural process quickly creates a deadly hazard. This animated diagram shows the core of Orion's life support mechanism, the amine swing beds. It relies on a chemical material that acts exactly like a sponge, physically trapping the moisture and carbon dioxide molecules floating in the cabin air. Once the sponge is full, the entire bed mechanically swings outward. It exposes that trapped material to the vacuum of space, which instantly boils the toxins away and flushes them into the void. The alternating beds run in a continuous cycle. One side absorbs the exhaled air, while the other side vents it to space, maintaining breathable oxygen levels and a stable 70-degree temperature. Surviving in deep space relies on engineering that flawlessly mimics the Earth's natural breathing cycles, condensed down into a single machine within a tiny, confined space. Beyond the air they breathe, the crew faces the invisible threat of piercing, unfiltered solar radiation streaming directly from the sun. If a violent solar flare erupts, the crew executes a specific emergency protocol. They retreat to the deepest part of the capsule and physically build a storm shelter, stacking their dense supply bags and equipment to create makeshift armor against the radiation strikes. Assuming they weather the journey, they will arrive at the moon. But instead of entering lunar orbit or attempting a landing, the crew will fly thousands of miles past its far side. This animated diagram illustrates their precise path, known as a free return trajectory. It is a calculated figure-8 route designed to bring the ship back to Earth naturally, even in a total loss of engine power. As the spacecraft rounds the far side, the moon's immense gravity catches it like a massive slingshot, bending its momentum and naturally pulling it right back toward Earth. It is the ultimate paradox of the mission. At their absolute furthest point from home, completely isolated in deep space, they are perfectly caught by the invisible laws of physics that guarantee their return. That gravity slingshot solves the problem of getting home, but it creates another. It accelerates the Orion capsule to a staggering 25,000 miles per hour by the time it hits the top of Earth's atmosphere. The only thing standing between the 4 astronauts and total incineration is the spacecraft's heat shield. During the uncrewed Artemis I test flight, this shield exhibited unexpected behavior. engineers discovered specific areas where the protective material chipped and cracked under the intense buildup of heat. Instead of completely redesigning the heat shield for this flight, NASA opted to modify the re-entry trajectory to reduce the thermal strain. This turns the final descent into an unforgiving, high-stakes test with human lives on the line. Every success in deep space navigation and life support engineering hinges on this single descent. If that blunt wall of material fails against the friction of re-entry, nothing else matters. Artemis II is a necessary bridge. It is the crucial proof that human beings can operate and survive in the harsh environment of deep space. Because these 4 astronauts are willing to test those deep waters, the crew that follows them on Artemis III will finally be able to step out of the boat and onto the lunar shore. But before that can happen, the Artemis II crew must survive the plunge. As the capsule tears through the atmosphere, the immense friction wraps the entire ship in a bubble of superheated plasma. That plasma acts as a physical wall, blocking all radio signals. Flight controllers in Houston will lose contact, plunging the crew into total silence. For several minutes during the most dangerous phase of the entire mission, they will be entirely alone. Which brings us to today's curious question. If you were strapped into that ship, watching the Earth shrink to the size of a marble out the window, what is the one thing you would miss the most? Drop your answers down in the comments below. If you're a curious mind, this is just the beginning. Check out the videos on screen to keep exploring with us.